interpolation. So y is equal to f of x is a given data function and y is a dependent variable, x is independent variable here. And the x values are given like x0, x1 and so on, comma xn. These are x values and the corresponding the functional values are f of x0, comma f of x1, comma and so on, comma f of xn. So these are x values. These are f of x values at x values, the corresponding functional values. So far, that means in unit 1, you have learned that how to derive interpolation formulas when the values of the function at equally spaced values of x. Suppose if the functional values are given at unequally spaced values of x, then those earlier formulas are not applicable. So that we have to proceed to derive interpolation formulas for unequally spaced values of x. Okay, so so far we have discussed about the how to derive interpolation formulas at equally spaced values. But now suppose the at unequally spaced values, those formulas which we have discussed earlier are not applicable. In that situation, we have to derive another formulas which are unequally spaced values of x. In this unit, we will study the Newton's divided difference interpolation formula. Newton's divided difference interpolation formula and Lagrange's interpolation formula. Lagrange's interpolation formula. Here, Newton's divided difference interpolation formula is derived by using divided differences. But Lagrange's interpolation formula is derived without using divided differences. What are the divided differences? We will discuss about this. However, we can observe that these two formulas are applicable even when the functional values are given at equally spaced values. Okay, so far we have discussed about the derivation of the interpolation formulas at equally spaced values. In this class, we are going to discuss about the derivation of interpolation formulas at unequally spaced values of x. So these formulas can be used at equally spaced values or unequally spaced values. So now, first of all, we will go to derive Newton's divided difference interpolation formula. For that, we have to know the definition of divided differences. Divided divided differences. Let y is equal to f of x is the given data function. Is the given function. And let x naught, comma x1, comma and so on, comma xn be the values of x. Values of x or arguments of x. Or we also call it as arguments of x. And the corresponding values functional values. The corresponding functional values or the corresponding values of f of x or f of x naught, comma, f of x1, comma and so on, comma, f of xn. Here, x values may be equally spaced values or unequally spaced values. So anyway, then we can define divided differences. Then the first order divided differences of f of x for the two consecutive arguments like x naught comma x1 or x1 comma x2, etc. are defined as f of x naught comma x1 is equal to, this is the first order divided difference of f of x for the two consecutive arguments x naught and x1. This is defined as the first value argument is x naught here, the second argument is here x1. So here it is defined as f of x1. It is related to the second value minus f of x naught. It is related to the first value x naught divided by x1 minus x naught. Suppose similarly, if you define the first order divided differences of f of x for the two consecutive arguments x1 and x2, it is defined as the first value, or first we can call it as argument. The first argument is x1, the second argument is x2. The first order divided difference according to x1 and x2 is defined as f of x2 minus f of x1 by, here the second value is coming, here the first value is coming, f of x2 minus x1 minus f of x1 by x2 minus x1. Similarly, we can define another first order divided differences. Next, we go to define second order divided differences. The second order divided differences of f of x for the function for the of f of x for the three consecutive values or arguments like x naught comma x1 comma x2 or x1 comma x2 comma x3 or x2 x3 x4 and so on. are defined as f of x naught, comma x1, comma x2. Take three arguments, x0, x1, x2. And the second order divide difference is defined according to x0, x1, x2. F of x1, comma x2 minus f of x0, comma x1 divided by x2 minus x0. If you observe this one, the first argument is here x0, the second argument is here x1, the third argument is here x3. And now this is the second order divided difference according to three arguments. Now it is defined as f of x1, x2, the last two arguments. Okay, f of x1, comma x2 minus f of x0, comma x1. Take the first two arguments minus f of x0, comma x1 by x2 minus x0. Take the last one minus the first one. Last one and minus the first one. x2 minus x0. So this is the second order divided difference of f of x for three consecutive arguments x0, x1, x2. Similarly, we can define the second order divided difference of f of x for three consecutive arguments x1, x2, x3, which is defined as take the second and third f of x2, comma x3 minus take the first two f of x1, comma x2 divided by x3, the last argument minus the first argument x1. Similarly, you can define the second order divide difference for three consecutive arguments x2, comma x3, comma x4, which is defined as take the second and third f of x3, comma x4 minus take the first two arguments f of x2, comma x3 divided by the last argument x4 minus the first argument x2. So like this, you can define the second order divided differences. Next, we go for finding the third order divided differences. Next, the third order divided difference for the four arguments. That is x0, x1, x2, x3. Four arguments are there. Is defined as f of, what are the four arguments here? x0, x1, x2, x3. So this is the third order divided difference. This is defined as take the last three f of x1, comma x2, comma x3 minus take the first three arguments f of x0, comma x1, comma x2 divided by last argument, that is x3 minus what is the first argument? x0. So this is the definition of third order divided difference. So we can define third order divided difference for another four arguments, that is x1, x2, x3, x4, like that. So what is this definition according to the above definitions? Take the last three arguments f of x2, x3, x4 minus take the first three arguments. What are these? f of x1, x2, x3 divided by last argument, that is x4 minus first argument, that is x1. So like that, we can define the third order divided differences for the given function f of x. So in general, the nth order divided difference for the n plus 1 arguments. What are the n plus 1 arguments? x0, x1, x2 and so on, comma, xn. So xn plus x0, totally n plus 1 values are there, n plus 1 arguments are there, is defined as f of, what are the n plus 1 arguments? x0, x1, x2, x3, x4 and so on, xn minus 1, comma, xn, like that. This is defined as, take these arguments, that is f of x1, comma, x2, comma, and so on, comma, xn, minus, take the first n arguments, f of x0, comma, x1, comma, and so on, xn minus 1, divided by, here xn minus 1 will be there, divided by, last argument is xn minus the first argument is x0. So like that way, we can define the divided differences in various orders for the given function. So anyway, we know that how to define the divided differences of various orders. So now, how to construct the divided difference table according to the definition of divided difference. Now, we are going to construct the divided difference table. So these divided differences, so whatever we have discussed just now, these are the definition of the divided differences. We can show all these definitions in the table like that. Draw the table like, what are the x values here? Argument. You can call it as argument here. So here I am taking 4 arguments, x0, x1, x2, x3. Now, take y is equal to f of x values. So at x0, f of x0, at x1, functional value is f of x1. At
Excuse
x2,
me, madam, we are unable to see the overwriting on the same page. It is overwriting on the same page.
Okay,
it is not appearing clearly.
Sorry. Okay. So now I will repeat this one, the table. Take all the definitions in the table. So this is the construction of the divide difference table. So the first column, in the first column, we are taking the x values or arguments. That is x, x0, x1, x2, x3. And take the values, f of x values in the second column, that is entry, y is equal to f of x. So for x0, the functional value is f of x0. For x1, the functional value is f of x1. For x2, the functional value is f of x2. For x3, the functional value is f of x3. And now, so what is the first order divided difference? First order divide difference. Simply, I am writing like this. take this first order divided differences in the third column. And now, what are the first order divided differences? According to the definition of divided difference, f of x1 minus f of x0 by x1 minus x0. What is this? F of x0 comma x1. Is it right? According to the definition what we have given just now?
Yes, yes.
Now, if we come into these two, according to these two, f of x2 minus f of x1 by x2 minus x1. That is f of x1 comma f of x1 comma x2. And now same you can define like this from the definition. F of x3 minus f of x2 by x3 minus x2. That is f of x2 comma x3. So this is the first order divide difference for x0 and x1. This is the first order divided difference for x1 and x2. And this is the first order divide difference for arguments x2 and x3. Now similarly, we can write the second order divided differences in the another column. So now, according to the definition, this f of x1 comma x2 minus this f of x0 comma x1 by x2 minus x0. What is this definition? F of x0 comma x0 comma x1 comma x2. So this means second order divided difference for three arguments, this x0, x1 and x2. So now if we coming to these two, according to this one and this one, f of x2 minus x3 minus, f of x2 comma x3 minus f of x1 comma x2 divided by x3 minus x1. x3 minus x1, that is f of x1. So according to this one, how many are there? x1, x2, x2, x3. That means x1 comma x2 comma x3. So anyway, this is the second order divide difference for three arguments x0, x1 and x2. This is the second order divide difference for three arguments x1, x2 and x3. So what is this definition? Second order divide differences in this column. Next, there is possible to get another column, that is third order divided differences. So now, if you observe this one, f of x1 comma x2 comma x3, this one, minus f of x0 comma x1 comma x2 divided by x3 minus x0, that is f of x0 comma x1 comma x2 comma x3. So this is the third order divided difference. There is no possible to get another divided difference order, that is fourth order divided difference. So we can restrict up to here there because there is no possible to get another definition or another order divided difference. So this is the definition of the divided differences, and these are the definitions of divided differences in various orders in the table. Now, from the definition of divided differences, the divided differences are symmetric functions. We can say that the divided differences are symmetric functions in their arguments, in their values. So for example, what is the first order divided difference for x0 and x1? What is the definition? Please tell me. F of x0 comma x1 is equal to the first order divided difference for x0 and x1. What is this? F of x1 minus f of x0 by x1 minus x0. So now if we can observe this one, anyway, this is the functional value. This is the functional value. This is the functional value. This is some value. This is some value, any value. So totally it can be shown that the value. So we take common minus from this one. Then we have minus of f of x naught minus f of x1 divided by, take common from this one, minus of x naught minus x1. So this can be written as this one. Now, which is equal to minus minus get cancelled. The remaining part is f of x naught minus f of x1 by x naught minus x1. So according to this definition, we can write it as f of x1 comma x naught, like that. So f of x naught comma x1 is equal to f of x1 comma x naught. So if you can write f of x naught comma x1 is equal to f of x1 comma x naught, the value cannot be changed. So that we can say that the divided differences are symmetric functions in their arguments. Suppose here this is the first order divided difference for x naught and x1. Suppose there is a second order divided difference for three arguments x naught, x1 and x2. And what is this definition? F of x1 comma x2 minus, next one, f of x naught comma x1 divided by, the last one is x2 minus the first one is x naught. So according to this one also, we can write it as f of, take common minus from this one. We can write f of x naught comma x1 minus f of x1 comma x2 divided by, minus, here also we can take common minus because this is the value. There is no change at all. X naught minus x2. So now minus minus get cancelled. Then we can write it as f of x naught comma x1 minus f of x1 comma x2 divided by x naught minus x2. So it can be written as f of x2 comma x1 comma x naught. So f of x naught comma x1 comma x2 is equal to f of x2 comma x1 comma x naught. So if this one is equal to this one, so that the divided difference for three consecutive arguments is symmetric function in their arguments x naught, x1, x2. So like this manner, if this condition satisfies, we can say that the divided differences are symmetric functions in their respective arguments. So anyway, till now, we got the definition of divided differences. So suppose we have seen that the divided difference, first order divided difference is symmetric function, second order divided difference is also a symmetric function. So in general, suppose there are n plus 1 arguments, is it symmetric or not? Definitely it is a symmetric. So that is f of x naught comma f of x naught comma x1 comma and so on comma xn minus 1 comma xn, there are n plus 1 arguments, is equal to, we can simplify this one as above. We get f of xn comma xn minus 1 comma and so on comma x1 comma x naught. So anyway, the divided differences are symmetric functions in their arguments. So now we go for another concept, that is example. For example, how to construct the divided difference table for the given data. First of all, we can see that how to construct the divided difference table for the given data, and later we go for how to derive Newton's divided difference interpolation formula. So first I am taking here example. What is the example? Construct the divided difference table for the given data. So what is the given data? X values and f of x values are given. The x values are 0, 1, 2, 4, 5. The f of x values are 1, 4, 15, 5, 6. So now, first of all, we have to observe the difference between these two consecutive x values 0 and 1, 1. What is the difference between 1 and 2? 1. What is the difference between 2 and 4? 2. The difference between 4 and 5 is 1. Anyway, these values are not equally spaced values. There is a difference. There is different differences. So that these are unequally spaced values. Okay. Now, first of all, in the solution, identify x0 value, x1 value, x2 value, x3, x4 values. How many values are there? 1, 2, 3, 4, 5. 5 arguments are there. And now the functional values are here. F of x0 is equal to 1. F of x1 is equal to 4. F of x2 is equal to 5. F of x3 is equal to, this is 15, 5. And f of x4 is equal to 6. F of x0 is 1, f of x1 is 4, f of x2 is 15, f of x3 is 5, f of x4 is 6. Now, using these tabular values, we are going to construct the divided difference table. The divided difference table to the given data is shown as follows. I'm going to change the page because the table, this space is not sufficient for doing the table. I'm drawing the table here according to the given tabular values. X values, f of x values in this column. And first to take the x values, 0, 1, 2, 4, 5. And now taking the f of x values in the second column, 1, 14, 15, 5, 6. Next what will we do?
Madam, 1, 4.
First order divided differences. So now we are going to take the first order divided differences according to the given values. So what is this value, ma? X0. What is this value? X1. This value is X2. This is X3. This is X4 value. This value is f of x0. This is f of x1. This is f of x2. This is f of x3. This is f of x4. if you can identify, no need to write like this. So please remember the general divided difference table. So now, what is the first order divided difference according to these two values, x0 and x1? This one, f of x1, that is 14, minus f of x0, that is 1, divided by, sorry. So if you want to have this one, I will write here, f of x1 minus f of x0 by x1 minus x0. What is this? If f of x0 comma x1, this one. So f of x1, that is 14, minus f of x0, that is 1 by x1,
madam, excuse me.
Is 1 minus
excuse
x0.
me, madam. Is it 4 or 1? 4 or 1, madam? It is 4. The second argument, the first, this one. F of x1 is equal to 4.
14. 4. 4. Okay, sir.
4, madam. Actually, I'm right.
14, ma. 14. It's not 4, 14. Correct it, ma, in the problem. 14.
Okay.
1 minus 0. So what is this value, ma? 14 minus 1 by 1. 13 by 1. That is 13. So according to this one, f of x1 comma x2. What is this formula, ma? F of x2, that is 15, minus f of x1, that is 14, by this one minus this one, divided by this one minus this one. That is x2 minus x1. What is x2 minus x1? 2 minus 1. So what is this value? 15 minus 14? 1. By 2 minus 1 is 1. So what is the next first order divide difference?
4. It is 4. It is 4 indeed. Again, you did not correct.
One,
you did not correct this 14 as 4, madam. Instead of 14, we have made 4 only. F of x1 is 4.
No, you take 14. According to 14, we will do.
Okay. Thank you. Okay.
You can correct in the problem.
Okay. Thank you.
In the
Thank
place
you, madam.
of 4, take 14. Okay. Next, we go to take another one. What is another first order difference? Divide difference. F of x2 comma x3. That is, what is this formula, ma? F of x3, that is 5, minus f of x2, that is 15, divided by x3 minus x2, 4 minus 2. What is this value? Minus 10 by 2. That is minus 5. Next, we go to take another first order divide difference, that is f of x3 comma x4. What is this definition? F of x4, that is 6, minus f of x3, that is 5, divided by 5 minus 4. x4 minus x3, that is 5 minus 4. So what about this value? 6 minus 5. That is 1. 5 minus 4, 1. That is 1. So now we go to take second order divided differences. So now what are the second order divide differences? F of, for 3 arguments, f of x0 comma x1 comma x2. So what is the formula here? F of x1 minus x2. What is that value? Tell me, what is that value? F of, what is this formula? F of x1 comma x2 minus f of x0 comma x1 by x2 minus x0. According to this one, this value, f of x1 comma x2 value is 1 minus f of x0 comma x1 value is 13 by x2 value is 2 minus x0 value is 0. So 1 minus 13 by 2 minus 0, minus 12 by 2, that is minus 6. Similarly, we can get another second order divide difference, that is for 3 arguments, x1 comma x2 comma x3. So what is this formula, ma? F of, same, follow this formula, same. F of x2 comma x3 minus f of x1 comma x2. So if you can identity, no need to write the formula here. Directly you can take the values x3 minus x1. According to this one, f of x2 minus x3 is minus 5 minus f of x1 comma x2 is 1 divided by, what is x3? 4 minus x1, 1. So minus 5 minus 1 by 4 minus 1 minus 6 by 3, that is minus 2. Next we go for another one, that is f of x2, x3 comma x4. So what is this formula? F of x3 comma x4 minus f of x2 comma x3. Divided by the last one minus the first one, x4 minus x2. So now substitute the values. F of x3 comma x4 is 1 minus f of x2 comma x3 is minus 5. That is plus 5. So x4, 5 minus x2, 2. 1 plus 5 by 5 minus 2, 6 by 3, that is 2. These are the values. Now we go to take another order, that is third order divided differences. So now this one minus this one. What is this third order divide difference for 4 arguments, that is x0, x1, x2, x3. So now what is the formula here? F of x1, x2, x3, that is minus 2 minus f of x0, x1, x2, that is minus 6, that is plus 6 divided by x3. What is x3? 4 minus x0, 0. Minus 2 plus 6 by 4 minus 0. 4 by 4, that is 1. Similarly, another third order divide difference in the same column is f of x1, x2, x3, x4. The formula is here. F of x2, x3, x4, that value is 2 minus f of x1, x2, x3, that value is minus 2, that is minus of minus plus, by x4 value 5 minus x1 value. What is x1? 1. 2 plus 2 by 5 minus 1, that is 4 by 4, that is 1. Now, you go to take another order, that is fourth order divided differences. What is the fourth order divided difference? This one, f of how many arguments will be there? 5. x0, comma, x1, comma, x2, comma, x3, comma, x4. Fourth order means up to x4. But how many arguments will be there? 5 arguments. So according to this one, the formula is f of x1, x2, x3, x4. That value is 1 minus. Next, f of x0, x1, x2, x3. That formula is this one, 1 by last one, x4. What is x4 value? 5 minus. First one, x0, that is 0. So 1 minus 1 by 5 minus 0. 0 by 5, that is 0. So anyway, these are the elements in the divided difference table. So after completing the construction of the table, what will we do? So what is the problem? In the problem, we asked only the construction of the divided difference. So this is the table of the various orders, divided difference for f of x, various arguments. Next, we go to take another problem, that is Newton's divided difference interpolation formula. So now we are going to learn how to derive Newton's divided difference interpolation formula. Newton's divided difference interpolation formula. Suppose y is equal to f of x is a given function. And suppose that f of x naught, f of x1, x2, and so on, f of xn are the values of the function y is equal to f of x corresponding to the values or arguments x0, x1, x2, and so on, xn, where x0, x1, x2, and so on, xn need not be equally spaced values. So that means x0, x1, x2, and so on, xn may be equally spaced values or unequally spaced values. If the values, suppose the values are equally spaced values, we can use this formula. The values are unequally spaced values, we can use this formula. So that we are using this word. These values need not be equally spaced values. So this is the fundamental given data. Now, after getting this data, we have to use the definition of divided difference for deriving the Newton's divided difference interpolation formula. So what is that? Then after completing this given data, then by the definition of divided differences, we have number 1, f of x, x0. Tell me what is, according to the divided difference, definition of divided difference for two arguments x and x0. What is the definition over here? F of
x minus f of no, f of x naught
minus
f of x naught minus f of x by x naught minus x.
x1.
So we know that already we spoken about this divided differences are symmetric functions.
yes.
So that we can write it as f of x minus f of x naught by x minus x naught. So we can write like this also. There is no problem. Okay. So now if we take f of x, x naught, we can write the definition f of x minus f of x naught by x minus x naught. Now You now cross multiply this one. That is x minus x naught into f of x comma x naught is equal to f of x, this one. F of x minus f of x naught. From this expression, we can write f of x. Therefore, f of x is equal to, what is f of x? F of x naught, this one, plus x minus x naught into f of x comma x naught. Give equation number 1 for this expression. So anyway, now we go to take another divided difference for 3 arguments. That is, now f of x comma x naught comma x1 is equal to, we can write it as f of x naught comma x1 minus definition, from the definition, minus f of x comma x naught divided by the last one is x1, the first one is x. So now the definition of the divided difference is symmetric, so that we can write it as f of x comma x naught minus f of x naught comma x1 divided by x minus x1. Now do the cross multiplication. This one, x minus x1 into f of x comma x naught comma x1 is equal to f of x comma x naught minus f of x naught comma x1. So now we can take this one, f of x comma x naught. Therefore, f of x comma x naught is equal to, what is the term? This term will come left, to the left. That is, minus will become plus. F of x naught comma x1 plus x minus x1 into f of x comma x naught comma x1. So give equation number 2 for this one. Now you can observe equation 1 and equation 2. In equation 1, we have f of x comma x naught. So here in equation 2, we have the value f of x comma x naught. So substitute 2 equation 2 in 1. Substituting equation 2 in equation 1, we get f of x. What is equation 1? F of x is equal to this one, equation 1. F of x naught plus x minus x naught. So now we have to substitute this from equation 2. What is this value? This one. F of x naught comma x1 plus x minus x1 f of x comma x naught comma x1. So then from this one, we can simplify this one. After simplifying this, we can get this one into this one plus this one into this one. Next, we go to take another page. So that is f of x is equal to f of x naught, and simplify this one. What is simplify this one? F plus x minus x naught into f of x naught comma x1 plus x minus x naught x minus x1 f of x comma x naught comma x1. So now give equation number 3. Now we go to take another order divide differences. That is f of x comma x naught comma x1 comma x2. So from this is the definition is here, f of x naught comma x1 comma x2 minus f of x comma x naught comma x1 divided by x2 minus x. So its divided difference is symmetric function, so that we can write it as f of x comma x naught comma x1 minus f of x naught comma x1 comma x2 divided by x minus x2. Now do the cross multiplication here. X minus x2 into f of x comma x naught comma x1 comma x2 is equal to f of x comma x naught comma x1 minus f of x naught comma x1 comma x2. Now we can get the value here, this one. Therefore, f of x comma x naught comma x1 is equal to f of x naught, this one, comma x1 comma x2 plus this one, x minus x2 into f of x comma x naught comma x1 comma x2. Now give equation number 4. Now substituting equation 4 in 3. What is the equation 3, ma? In equation 3, we have f of x comma x naught comma x1. So from equation 4, we have the value f of x comma x naught comma x1. So that we can substitute 4 in 3. Substituting equation 4 in 3, we get f of x is equal to equation 3, this one. F of x naught plus x minus x naught, f of x naught comma x1 plus x minus x naught, x minus x1 into, substitute this value from equation 4. What is this value from equation 4? F of x naught comma x1 comma x2 plus x minus x2 f of x comma x naught comma x1 comma x2. Now simplify this one. So multiply this one by this one. That means simplification. Therefore, f of x is equal to, the first term is as it is, plus the second term is also as it is, and the third term will be simplified. That is x minus x naught into x minus x1, this one into this one, f of x naught comma x1 comma x2 plus this is this one into this one. Next, x minus x naught into x minus x1 into x minus x2, f of x comma x naught comma x1 comma x2. So this is, we can continue this process up to n plus 1th order divided differences. So we can continue this process up to n plus 1th order divided differences. We get, that means in general, f of x is equal to f of x naught plus x minus x naught, f of x naught comma x1 plus the first term, the second term, and the third term is this one, x minus x naught, x minus x1, f of x naught comma x1 comma x2 plus and so on, plus the last term is x minus x naught, x minus x1, and so on, x minus xn minus 1, x minus xn, f of x naught comma f of x comma x naught comma x1 comma x2, sorry, here f of x comma x naught comma x1 comma x2 comma and so on comma xn. This is the generalization. So now if you observe in this one, f of x naught, so for 2 x naught and x1, we have only x naught, this one. For 2 x naught, x1, x2, 3, for 3 x naught, x1, x2, we have x naught and x1 only. So according to this one, for n plus 1, x naught, how many are there? X, x naught, x1, and so on, xn. We have up to x naught, x1, and so on, xn only. So that means xn plus 1 are there. These are xn plus 2. X1 to xn are n values, and x naught is n plus 1 value, and x is n plus 2 values. If n plus 2 values are there, n plus 1 values will come. If 3 values are there, 2 values will come. If 2 values are there, 1 value will come. So that is the logic to write the formula. Next, we go to take this one. We can rewrite this formula as, observe this formula. So I'm going to next page. That is f of x is equal to the first term. Observe this one. The first term is as it is, and the second term is as it is. In the second term, only x naught and x1 are there, and the factor is only x naught. Plus the third term, x minus x naught into x minus x1 into f of, how many arguments will come? X naught, x1, x2, 3 arguments. Plus, and so on, plus the last one is x minus x naught, x minus x1, and so on, x minus xn minus 1, f of x naught comma x1 comma and so on comma xn. So if we can observe this formula, so how many arguments are there? 2, x naught and x1. Only the factor will restrict up to x naught only. So how many arguments are there in this term? X naught, x1, x2. The factors will restrict up to 2, x naught and x1 only. Similarly, in the last term, how many arguments are there? X naught, x1, and so on, xn. So n plus 1 arguments are there. Is it right? So so these factors will restrict up to n terms. So x naught, x1, and so on, xn minus 1 means n terms. So this is the formula. So this formula is known as Newton's divided difference interpolation formula, or Newton's general interpolation formula with divided differences. This is the polynomial of degree at most n. So if we can simplify this one with the given data, given functional values or x values, with that data, we can get some polynomial. So according to this formula, this is the polynomial of degree at most n. Next, we go to text. So far we have completed the concept of derivation of Newton's divided difference interpolation formula. Now I am going to take example here. So find the polynomial for the following data. What is the given data? X values, f of x values, -1, 0, 3, 6, 7. Next 3, f of x values, -6, 39, 822, 1611. This is the given tabular values, and now we are going to find the polynomial. So observe this, and what is the difference between these two values, x0 and x1, -1. And what is the difference between 0 and 3? 2. What is the difference between 3 and 6? 3. What is the difference between 6 and 7? 1. So anyway, these x values are not unequally spaced values. These are unequally spaced values. So if these, we can use the Newton's divided difference formula, or we can suppose in this problem the x values are at equidistant values. Then also we can use Newton's divided difference formula, or also there is at that case there is possible another interpolation formulas which we have discussed in previous classes. But if the x values are at unequally spaced values, only we have to use Newton's divided difference interpolation formula, and one more formula will be there, we will discuss later. At this case only. Now we go to find the solution. So from the problem, identify the x0 value, x1 value, x2 value, x3 value, x4, 7. 1, 2, 3, 4, 5. x0, x1, x2, x3, x4. 5 values are there. And the functional values f of x0 is 3, f of x1 is -6, f of x2 is equal 39, f of x3 is equal to 822, and f of x4 is equal to 1611. Now, first we have to find the polynomial, we have to take the Newton's divided interpolation formula. So how many values are there, arguments are there? 1, 2, 3, 4, 5. So according to these 5 values, we can write the Newton's divided difference interpolation formula. Let us see that. Newton's divided difference interpolation formula is f of x is equal to f of x0 plus x minus x0, f of x0 comma x1 plus next term x minus x0, x minus x1, f of x0 comma x1 comma x2, 3 arguments will come, plus then the coming term will be like x minus x0, x minus x1, x minus x2 into f of, how many arguments will be there? x0 comma x1 comma x2 comma x3, plus the another term is next term x minus x0, x minus x1, x minus x2, x minus x3, f of, how many arguments will come? x0, x1, x2, x3, x4. So there are 5 arguments. So 1, 2, 3, 4 are there up to x3. So like that manner, we can define the formula. We can restrict up to here because we have the 5 arguments from x0 to x4 from the problem, so that we can stop at this term. Okay, this is the Newton's divided difference formula. Now, what is this value? So we know that x0 value, x1 value, and x2 value, like that we know that these are. But we don't know f of x0 comma x1, f of x0 comma x1 comma x2, and f of x0, x1, x2, x3, and f of x0, x1, x2, x3, x4. So we don't know all these values. For getting these values, what will we do? For getting these values, what will we do, ma? We have to construct divided difference table for the given data. Is it right?
Yes, ma'am.
So now construct the divide difference table. Now, sorry, I'm taking another page. Now construct the divided difference table for the given data. So now what is the table? How can we construct it? So first take the x values in the first column. What are the x values, ma? 1, minus 1, 0, 3, 6, 7. Next one, f of x values in the next column. Take f of x values.
3,
3,
minus 6,
minus 6,
39,
39, 822, 1611. So now the first order divided difference. So this is x0, this is x1, x2, x3, x4. F of x0, f of x1, f of x2, f of x3, f of x4 values. So now first order divided differences are f of x0 comma x1 is equal to minus 6. F of x1, that is minus 6 minus f of x0. What is f of x0, ma? 3 by x1 minus x0, 0 minus minus 1. So minus 6 minus 3 by 1, that is minus 9. Similarly, you can take f of x1 comma x2. So what is this formula? F of x2, that is 39 minus f of x1, that is minus 6 by x2 minus x1, 3 minus 0. So what is this value? 39 plus 6 by 3, 15. Similarly, f of x2 comma x3 is equal to, what is this formula? F of x3, that is 822 minus f of x2, that is 39 by x3 minus x2, 6 minus 3. What is this value? Use the calculator to get the values. 261. So the next value is f of x3 comma x4. F of x4, 1611 minus f of x3, 822 by x4 minus x3, 7 minus 6. What is this value, ma?
789.
789.
Ma'am, 39 minus 6 దగ్గర 15 కాదు 45. 39 minus of minus plus కదా.
39 minus of minus 6.
మా 6 కి
40.
minus కదా మేడం 45.
Yes. 45 by 3.
15 only.
15 only.
45 by 3, 15 kadamma.
Okay madam.
Okay ma? Okay or not?
Okay ma'am.
Okay. Next we go for another second order divided differences. What is that formula? F of x naught comma x1 comma x2 is equal to. So keep the formula or the definition of divided differences in your mind according to the various orders. No need to write always while constructing the table. So what is this formula? F of x1 comma x2, this one, minus f of x naught comma x1, this one, by x2 minus x naught, 3 minus of 1, 15 minus 15 plus 9 by 3 plus 1. What is this value? 6. Similarly, f of x1 comma x2 comma x3 is equal to, what is this formula? F of x2 comma x3, that is 2261, minus f of x1 comma x2, that is 15 value, divided by x3 minus x1, 6 minus 0. So what is this value? 41. Next value, next formula, f of x2 comma x3 comma x4 is equal to. So f of x3 comma x4 is 789. F of x2 comma x3 is 261 divided by x4 minus x2, 7 minus 3. This value is 132. So now we go to take another order, that is third order divided differences. So now third order divided differences means f of x naught comma x1 comma x2 comma x3. So the formula is here, f of x1 x2 x3, that is 41, minus f of x naught x1 x2, that is 6, divided by x3 minus x naught. x3 is 6, x naught is minus 1. So 41 minus 6 by 6 plus 1. What is this value? 5. Next one, f of x1 comma x2 comma x3 comma x4. The formula is here, f of x2 x3 x4, that is 132, minus f of x1 x2 x3, that is 41, by x4 minus x1, 0, 7 minus 0. This value is 30. So there is possible to get another order, that is fourth order divided differences. That formula is x naught comma x1 comma x2 comma x3 comma x4. This is equal to. So next, this formula is f of x1 x2 x3 x4, 13, minus f of x0 x1 x2 x3, that is 5, divided by x4 minus x0,
minus 1.
minus 1, 7 minus of minus 1. The value is here 13 minus 5 by 7 plus 1, that is 8 by 8, 1. So this is the construction of the table. And now we are going to substitute relevant values in the formula. Once you have to see the formula which I have written in the previous page, you can see that one. In the formula, the first term is f of x naught. Okay, that is this one, 3. In the formula, in the second term, f of x naught comma x1, that is minus 9. Remember this. In the third term, f of x naught comma x1 comma x2 is, the value is 6. And in the formula, the last term is f of x naught, x1, x2, x3. That value is 5. Is it right? So now substituting all these relevant values in the formula. substitute all the relevant values or corresponding values in the formula. We get I'm going to take another page here. You have to tell me what are the values in the formula. Okay. So f of x is equal to, what is f of x naught, ma? What is f of x naught? 3 plus, what is the another term? X minus x naught. So x minus, what is x naught, ma? Minus 1. That is plus 1. Next, f of x naught comma x1 is minus
Minus 9.
minus 9. Like that, you have to substitute all the values. Ma. X minus x naught, that is. Next, x minus x1. x1 value is 0. Next, f of x naught, x1, x2 value is 6. Plus, next, x minus x naught, that is x plus 1, x minus x1, x minus x2. What is x2? 3. F of x naught, x1, x2, x3 value is 5. Plus, next value, x minus x naught, x plus 1, x minus x1, that is x minus 0, x minus x2, that is x minus 3. X minus x4, that is x minus 7 into f of x naught, x1, x2, x3,
13,
x4 value.
13. 1, 2, 3. X minus 7.
1 kadamma. 4. Order is 1, 2, 3. Third order kada.
Yeah, correct.
1. So all are coming, ma. Minus 9 is coming. This is first order value. 6 is minus 9 first order value. 6 is second order value. And 5 is third order value. And 1 is fourth order value. All are coming. Okay. Next. Now simplify this one. 3 minus 9x minus 9. Minus 9x minus 9. And 6x square. 6x square. 6 plus 6x. Next one. X plus 1 x plus 1 x minus 3 into 5 plus x plus 1 x minus 3 x minus 7. So anyway, 3 minus 9x minus 9 plus 6x square plus 6x plus 5x. So this is, simplify this one here, 5x into x plus 1 into x minus 3. What is this value? This value, 5x into x square minus 3x plus x minus 2x minus 3. So 5x cube, so I am writing here 5x cube, this value, 5x cube minus 10x square minus 15x. Simplify this one, this value. Okay. So 5x cube minus 10x square minus 15x. Okay, right. Next point. Next term, this one. What is this value? X square plus x. This one. And what about these two? X square minus 3x minus 7x minus 10x plus 21. So now simplify this one. X to the power 4 minus 10x cube plus 21x square, this one, plus x cube minus 10x square plus 21x. So x to the power 4 minus 8x cube So now simplify all these values. We get x to the power 4. How many terms are there? Only one term. My x cube. What is x cube? 5 plus 5 plus 1 plus 4, 6
minus
minus 10 minus 4 5 minus 10 minus 5 minus 4 5 minus 8 minus 3. Is it right, ma? X cube terms x to the power 4 minus
x cube
minus 8 x cube.
9x cube, ma'am.
So what is the x cube values? What is the factor? This
9x
one
cube.
minus 3 na 4
9x cube.
9
minus 4, madam.
4x cubed. Minus 4x cubed.
Minus 4x.
minus 4x cube. Next x square terms 6 minus 10 minus 4 minus 4 21 17
17x square.
17 10
Plus 7.
7x square.
plus
7x.
7 huh?
Yes, ma'am.
Next x values minus 9 plus 6
Minus
minus 3 minus 15 minus 18
21.
minus 18 21
Plus 3x.
plus 3x. Next 6 constant values minus 6.
6.
Only
Simplify.
minus.
ఓకే మా సింప్లిఫై జాగ్రత్తగా చేసుకోండి. దేర్ ఇస్ నో ప్రాబ్లం. ఇఫ్ ఇట్ ఈస్ రైట్ ఆర్ రాంగ్ యూ కెన్ డూ ఇట్.
Thank you very much, madam.
Okay, madam. Thank you.
This is the procedure of the finding polynomial interpolation by using the Newton's divided difference formula. And also one more example will be there, but time is not there. So we will continue in the next class. Okay, thank you.
Thank you, madam.
Thank you, madam. Thank you, madam.
Yes.